Kirkle Math. All right, here we go. We are doing the last lesson. That's right, the last lesson of Module 13.3. There's only 3 of them. It's not too bad. We are going to find the volume of a sphere this time. So we're dealing with all these objects, these 3D objects that have circles in them. So a sphere looks like this, okay? The volume of a sphere is 4/3 pi times the cube of the radius. So we are going to cube our radius, and I'll show you how to do that on your calculator today because we've been doing squares and it's been a while since we've done any other exponents. But this is your formula right here, okay? The volume is 4/3 of pi times the radius cubed. Now, just like in our cones, we can actually write this lovely fraction a little bit differently. So in your notes, if you want to write it like this, doing 4/3 times something is the same as doing 4 times pi times r cubed and then dividing everything by 3. So we're going to go ahead and do 4 times pi times r cubed and then divide everything by 3. So this is another way that we're going to probably going to do this more often on our calculator. So this is one way that you can write down that formula. And this all has to do with the space that a sphere makes. I don't have a fancy diagram for this one, but we're going to just jump into some problems and show you kind of how that works on a real sphere. Okay, so this problem right here, we're going to find the volume of this sphere. We're going to use 3.14 for pi, and we're going to round to the nearest tenth. So I'm going to start by writing out that formula. I'm going to write out the second one that I wrote, 4 times pi times r cubed divided by 3. And then I'm going to take the information that I'm given. So because this is just half of my diameter from center there, this is my radius. So I'm just going to plug that in. So my volume is really 4 times 3.14 for pi times my radius cubed. And then all of this is going to be divided by 3. So let me show you how I do this on my calculator. So I'm actually going to pull my calculator over here so you can see it better. Whoops. Okay. And we are going to go ahead and show you how to do this right here. So let me switch from standard to scientific. So those black calculators that you have in class, those are scientific calculators, and you'll see the same symbols as they are here on my scientific calculator on the screen. So I'm going to go ahead and calculate this formula right here, but remember exponents come first. So I'm going to do my 2.1 cubed first. So to do that on a calculator, I'm looking for this symbol right here. So sometimes it looks like x to the power of y, and sometimes it looks like y to the power of x. It depends on your calculator. But to do 2.1 to the power of 3, I'm going to type 2.1 my base. Then I'm going to press that special exponent button, and you can see it brings this little caret symbol up, which means it's raised to the power of, and I want to raise it to the power of 3, and we're going to hit equals there. So that is going to be what 2.1 cubed is going to equal. Let me bring that up again. It was 9.261. Okay, so that is now part of my formula. So I am now going to continue using my calculator with these numbers right here. 9.261 all divided by 3. And I'm just going to calculate. So I already have this part down here, so I'm going to times that by 3.14, times that by 4, and then all of this gets divided by 3. So in the end, I'm going to get 38.77, and if I'm rounding to the nearest tenth, we're going to round up and get 38.8. So my volume here is 38.8 centimeters, and because it's volume, it's going to be cubed. That's how I find the volume of a sphere. So similar technique as what we did in our other stuff, we just have a new formula. We're just replacing whatever variable or symbol we have with the number that it represents, and then we're solving it using our calculator. Let's try another one. All right, so here we have another one, but this one is the full diameter. So because my diameter is 7, I know that a radius is half of a diameter. I know that my radius has to be half of 7, which turns out to be 3.5. So I'm going to do my formula. 4 times pi times radius cubed divided by 3. And I'm going to replace what I know. Pi is 3.14. My radius is 3.5, and I'm going to cube that and divide by 3. So now I'm going to use my calculator. So here we go. Clear this. I'm going to do 3.5, my little special exponent button, x to the power of y or y to the power of x, 3. That's going to get me my cube right here, so 42.875. Now I'm going to times that by 3.14 times 4, divide by 3. Now I round. I don't need a round earlier. You can just leave that on your calculator and keep multiplying and then divide. Once you get to your final step, that's when we're going to round. So because I'm going, it's hard to see here. Hold on. Let me pull this guy up a little bit better. Okay, a little bit better. Okay, so because I'm rounding to the tenths here, I'm going to look 1 to the right. It's a 0, so I'm going to keep it 1. My volume is 179.5 centimeters cubed. And that is going to be my answer for this next problem. All right, so just in true form, we're going to start doing some word problem ones, and we will do a reversed one where we're given the formula. So here we have a word problem. We have some soccer balls, some sports equipment here. They come in various sizes. One of the soccer ball has a diameter of 22 centimeters, and we want to know the volume of it. We're going to round to the nearest tenth and use 3.14 for pi. So again, I'm going to use that formula. V equals 4 pi r cubed divided by 3. And I'm going to start filling in. So I know that pi is 3.14. My radius, it tells me my diameter is 22. So all the way across this soccer ball is 22. So what is just half of that soccer ball? So if 22 is my diameter, I'm going to do 22 divided by 2 to make my radius. That is 11. Okay, so this is going to be 11 cubed. And I'm dividing by 3. I'm going to use my calculator to figure out what 11. Here's my little exponent button to the power of 3 is. Okay, and I'm going to go ahead now and do 4 times 3.14 times 1,331. All of this divided by 3. Okay, we're going to now multiply this out and solve. So 133.1 times 0.14 times 4 divided by 3. And we are going to get a very large number. I don't know if I did that. Oh, we're using centimeters, yeah. Okay, so we're going to say that this volume is 5,572.5 because we're rounding up centimeters cubed. That is going to be the volume of this soccer ball right here. Okay. Same type of stuff we've been doing. Remember, your diameter is really double your radius. So if I cut my diameter in half, I get my radius. Okay, now we have our reverse problem. So we have a volume that's given, okay? So in our formula, volume equals 4 pi r cubed divided by 3. I know my volume, okay? So I'm going to start replacing the things I know. I know that my volume is 288 pi, okay? I don't know the diameter of the soccer ball or the radius of the soccer ball. So the thing I'm trying to find is r right there. So I am going to plug in the stuff I know, like pi. I don't know what my radius is. Divide by 3. And I'm going to get the r all by itself. This is the thing right here that I want to get alone. on one side. So in order to do that, I need to first get rid of this division bar by doing the opposite of division and multiply by 3 on both sides. Okay. And when I do that, I'm going to get, this is cancels out, and I'm going to get 4. I'm going to put pi back in the symbol format because we have our symbol pi over here. So I'm just going to keep it that way. Should have done that in the first place. And I'm going to do 288 times 3. And that's going to get me 864 times pi. Now I can divide by pi because I know that that will cancel out on both sides. And you're left with 864 equals 4r cubed. Divide by 4 on both sides because, again, what is the thing I'm trying to get all by myself? And you can even do this. You can circle it on your own if you're getting stuck. Like, where is that thing I'm trying to find? It's this guy, this guy, this guy. What do I need to get rid of? The 4. That way that I can get r cubed by itself. Okay, so now I am going to do 864 divided by 4, and that's going to get me 216 equals r cubed. Now this is the spot where it's going to get a little different again. If you remember back to when we had, I think it's just volume of everything. When you had like r squared equaled a number and we did a square root to get rid of it. Well, we're going to do that same thing over here, but we're doing it with a cube root. So we're actually going to do r cubed cube root. Okay, I'll do the opposite to get rid of that cube and get me just r. But that's where it gets a little tricky because on our calculators, we don't always have these buttons, right? So I'm going to try to make this a little bit bigger so you can see the buttons better. But on here we have a square and we have the square where we did our cube here. If I hit this button here, it's almost like shift on your calculator or second. It's going to give me a new list of buttons here. And you can see I actually have a cube button that I could be using. You might have one on your scientific calculator if you look. But the thing that I want to use right now is this button right here. And again, it can look in two different ways. Some calculators show X with Y inside. Some calculators show X in the inside with Y on the outside. Either way, this is the one where you get to customize what goes inside your root button or your radical button and what goes outside your radical button. So what we're going to do is we're going to type 216. We're going to type one of these symbols right here. So in this case, this one. And then we're going to type the 3. So 216, this button right here, root button, and a 3. And it's going to be 6. 216, the cube root of 216 is 6. And that is my radius. But again, is that what it's asking me? No, it's asking me for the diameter. Okay, so on the diameter, again, if you go back in our notes, a diameter is just 2 times the radius, or half of the diameter is the radius. So if I have the radius, I'm going to go ahead and times that by 2. And that will get me my diameter of 12. So in this problem, the diameter of the soccer ball is 12. All right, so we're going to practice these two things. So this is a great time for you to pause your video and try to find the volume of these spheres on your own, and then you can join us again and see if you get it right. And we're also going to add in a little information about some other stuff that might happen. Okay, so that is what your answers are going to be here. So you can check your work. Just so you know, sometimes in certain problems, they might ask you for half of a sphere. If that was the case, if this problem asked us for half a sphere, we would just take our final volume and divide by 2, because we use half spheres in a lot of things. You might be talking about an ice cream cone, and that's the top half of the ice cream cone. Or a lot of the times we have mounds of dirt and we're looking for an approximate volume of that. So if for some reason it asked you to divide by 2, you would just